a mentorship program for educators in data analysis with Python, featuring linear regression and histograms. Please subscribe to the channel and share it with your friends. Author's video and white paper on AI engines. Pradeep K. Suri. Author, researcher, and AI DNN architect. Book for your library. Scan QR code, bookstore in the cloud. This program leverages AI tools to create an engaging and effective learning experience for students in linear regression. However, human mentors play a crucial role in guiding students and fostering deeper understanding. Here's a breakdown of the content we are offering in our mentorship program. Part 1, Building the Foundation. Introduction to Linear Regression. Explain the concept of linear relationships between variables. Introduce the basic equation of linear regression, y equals mx plus b. The equation y equals mx plus b represents the slope-intercept form of a straight line. It's a common way to express the relationship between two variables, x and y. Here's a breakdown of the terms. Y, this represents the dependent variable. Its value depends on the value of x. M, this is the slope of the line. It tells you how much y changes for every 1 unit change in x. A positive slope means the line goes up as you move to the right. A negative slope means the line goes down as you move to the right. A slope of 0 means it's a horizontal line, no change in y. X, this represents the independent variable. It's often used as the input value. B, this is the y-intercept. It represents the point where the line crosses the y-axis, when x equals 0. Imagine a graph with x on the horizontal axis and y on the vertical axis. The equation y equals mx plus b describes which points fall on the corresponding straight line. Here are some additional points to consider. This equation is just one way to represent a line. There are other forms, such as point-slope form or standard form. You can use this equation to find the slope and y-intercept of a line if you are given its formula. You can also use this equation to find the equation of a line if you are given its slope and y-intercept or 2 points on the line. Understanding data. Discuss the importance of data quality and cleaning in linear regression. Introduce different data visualization techniques, scatter plots, histograms, to explore data relationships. Mentor-led activity, students analyze sample datasets relevant to their interests. Part 2, Utilizing AI tools. Interactive learning simulations. Introduce the AI-powered learning platform with simulations for practicing linear regression concepts. Mentor guides students in selecting appropriate simulations based on their learning goals. Students work on simulations, receiving immediate feedback from the AI on their approach. Mentor facilitates discussions on the results and identifies areas for improvement. Automated grading and feedback. Explain how the AI grades quizzes and assignments, highlighting key strengths and weaknesses. Mentor helps students analyze the AI feedback and develop targeted study plans. Part 3, Deepening Understanding. Interpreting results. Mentor leads discussions on interpreting the slope, intercept, and R-squared values of the linear regression model. Discuss the limitations of linear regression and how it might not always perfectly represent real-world relationships. Students practice interpreting AI-generated model results on different datasets with mentor guidance. Exploring applications. Mentor presents various applications of linear regression in their chosen field, example education, business, science. Students explore real-world datasets relevant to their interests and brainstorm potential applications of linear regression. Mentor-student collaboration on a project where they use AI tools to analyze data and create a linear regression model for a chosen scenario. Part 4, Building Soft Skills. Effective communication. Mentor facilitates group discussions and presentations related to linear regression projects. Students practice explaining their findings and conclusions clearly and concisely. Collaboration. Mentor encourages teamwork during projects where students work together on data analysis and model building. Students learn to communicate effectively, share ideas, and resolve conflicts constructively. Developing a growth mindset. Mentor provides positive reinforcement and encourages students to learn from mistakes in their AI simulations and projects. Students develop resilience and perseverance when facing challenges in applying linear regression concepts. Additional considerations. Tailoring content to student needs. The mentor should assess individual student strengths and weaknesses to personalize the learning experience. Incorporating student feedback. Regularly solicit feedback from students on the program content, AI tools, and mentorship approach to ensure continuous improvement. Showcasing career opportunities. Highlight how linear regression skills are valuable in various fields to motivate students. By combining AI-powered learning tools with effective human mentorship, this program can empower students to develop a strong foundation in linear regression, hone critical thinking skills, and gain confidence in applying their knowledge to real-world problems. Exercise 1. Histograms. Break down the histogram image step by step. 1 histogram of hours studied, blue. The top histogram represents the distribution of hours studied. The horizontal axis ranges from 1 to 9 hours. The vertical axis shows the frequency, number of students, who studied within each hour range. For example, the bar at 6 hours indicates how many students studied for approximately 6 hours. 2 histogram of previous scores, green. The middle histogram represents the distribution of previous scores. The horizontal axis spans from 60 to 90 score intervals. The vertical axis shows the frequency of students who achieved scores within each interval. For instance, the bar at 70 represents the number of students who scored around 70. 3 histogram of predicted math scores, red. The bottom histogram depicts the predicted math scores. The horizontal scale ranges from 45 to 85, predicted scores. The vertical axis displays the frequency of students falling into each score range. For example, the bar at 80 corresponds to the number of students with an estimated score near 80. These histograms help visualize how data is distributed across different intervals. They're commonly used in statistics and educational analysis. Exercise 2. The scatter plot graph titled Actual vs Predicted Math Scores compares the actual math scores of students with the predicted scores generated by a model. Let's break it down. Horizontal axis, actual scores. The x-axis represents the actual math scores, ranging from 30 to 90. Each point on this axis corresponds to an individual student's actual math score. Vertical axis, predicted scores. The y-axis represents the predicted math scores, also ranging from 30 to 90. Each point on this axis corresponds to the predicted math score for the same student. Data points, the blue dots represent individual data points. Each dot pairs an actual score with its corresponding predicted score. Line of best fit, the red dashed line diagonally crosses the graph from the bottom left corner to the top right corner. This line represents the mathematical relationship between actual and predicted scores. It suggests a positive correlation. As actual scores increase, so do predicted scores. In summary, this graph evaluates how well the predictive model performs by comparing its predictions with actual math scores. Why have we used the following libraries? Import NumPy as NP. Import Pandas as PD. Import matplotlib.pyplot as PLT. From sklearn.model_selection import train_test_split. From sklearn.linear_model import linear regression. From sklearn.metrics import mean_squared_error, R2_score. Certainly, here's a breakdown of the Python libraries you've imported. 1. Pandas, PD. Powerful library for data analysis and manipulation. Used for loading data from various sources, CSV, Excel, SQL databases. Cleaning and transforming data, handling missing values, inconsistencies. Preparing data for modeling, feature engineering, creating new variables. 2. Matplotlib.pyplot, PLT. Library for creating static, animated, and interactive visualizations. Used for creating various plots and charts, line charts, scatter plots, histograms. Visualizing data distributions and relationships between variables. Customizing plots for better presentation. 3. Sklearn.model_selection, train_test_split. Part of scikit-learn library for splitting data into training and testing sets. Used for dividing data into two subsets, training data and testing data. Training data is used to fit the machine learning model. Testing data is used to evaluate the model's performance on unseen data. Ensures the model doesn't overfeed to the training data. For sklearn.linear_model, linear regression. Part of scikit-learn library for fitting and using linear regression models. Used for creating and fitting linear regression models. Linear regression models a relationship between a dependent variable, what you want to predict, and one or more independent variables, features used for prediction. Used in tasks like forecasting, trend analysis, and building simple machine learning models. 5 sklearn.metrics, mean_squared_error, R2_score. Part of scikit-learn library for evaluating the performance of regression models. Mean_squared_error. Calculates the mean squared error between the predicted values by the model and the actual values. Lower mean squared error indicates a better fit. R2_score. Calculates the coefficient of determination, R², of a model. R² represents the proportion of variance in the dependent variable that can be explained by the independent variables. Higher R² indicates a better fit, typically between 0 and 1. In summary, these libraries provide a comprehensive toolkit for data analysis, data visualization, and building basic machine learning models using linear regression in Python. Thank you.